I want to build an authentication system using sessions that is fast and scalable. So that's why I'm using Redis database, which is known for its sub-millisecond speeds. Additionally, I'm using the ElastiCache service in which I can enable clusters. And this clusters allow me to use the horizontal sharding technology. Now, to understand what horizontal sharding is, we first need to understand its underlying concept, which is horizontal scaling. All right. And so this is a type of scaling which we can use. So there are two, just for context. There's vertical scaling and then there's horizontal scaling, as I said, or scaling up for vertical scaling and then scaling out for horizontal scaling. Just a different way of saying it. So for vertical scaling, right, all you're essentially going to be doing is you're going to be upgrading the hardware on that server. So you only have one server which hosts your service, in this case my ElastiCache, and what we're doing is we're essentially just going to keep upgrading the instance, right? So we're just going to keep upgrading, right? We're going to keep upgrading these instances over here to more better and more powerful uh, hardware, all right? And that way we are vertically scaling. But now this poses several issues. The most notable one being that if we keep upgrading, it'll eventually reach a point where you cannot upgrade anymore. All right. And in that case, you're going to have to adopt a horizontal scaling method, right? And so a horizontal scaling, which is more well known and more used within software companies, is when you are not going to be upgrading the hardware necessarily, right? As you can see in this case, it becomes big to symbolize that, oh, the hardware became buffier, it's much more better in terms of from before. But in this case, the hardware will stay the same. But what we're going to be doing is we're going to be spinning up new instances of the same server or service. Okay? And so as you can see, that's why there are multiple servers. What we are doing is instead of relying on only one server and then just making it more powerful to handle more load, we are going to be creating more servers, right, and distributing our load to each server. And the way that we distribute this load is through a load balancer, also provided through AWS. So that is how we do horizontal scaling or vertical scaling. But now this really can only work on servers. It can't really work with databases, right? Because in databases, you have data, right? And this data needs to be in one central database, meaning that you can only really do vertical scaling, right? Because it's only one, remember, it's only one database and you're just upgrading its hardware, right? You can't really have multiple databases because it will lead to confusion, right? Well, you're wrong. There is a way of doing horizontal scaling with database solutions that is proven to be actually scalable, and that is horizontal sharding. All right. Now, horizontal sharding is essentially when we break our big database into multiple small databases and we're putting a portion of data in each database. So instead of having this huge central database which has all of our names, as you can see here, we are going to be splitting it up into different databases, also known as shards, which have a portion of the database, as you can see here. All right. And the way that we actually separate the data into these different shards is through a specific field or a specific hash, which we encrypt based on a specific field. All right. And so in this case, we're doing range-based sharding, which is actually how ElastiCache works with their sharding. And that just means that we take a range of numbers based on a numerical field. In the case of ElastiCache, we are just encrypting the key value, right? Because again, it's Redis, it's key value pair. We're encrypting it with a hash, and then we're using that number from the hash which it generates to give a range, right? And we can actually see that over here. If I scroll down, you'll see that it actually gives me a range over here. And these are the ranges of the hash based on the key that you get, right? So it just converts the key into a hash, which gives us a number. And then based on the number, whichever range it fits into, it will save in that shard. So this way, first of all, it'll be much more faster and much more scalable because you have multiple shards, meaning that the network and the data can be distributed, right? It can be distributed within each of these databases, right? Additionally, though, other than that, obviously, you're distributing your network, so then there's less load on each of these databases, and also there's less data within each database because it's only a portion. That's all well and good. But additionally, other than that, there's another secret little hidden benefit. And that is, if one of these databases go down, you still have the other shards that you can rely on, meaning only some of the users are affected rather than all. All right, so it allows for a more fail-safe option. Because let's say we do not use sharding and we just use vertical scaling, right? We just make it more buffier and the hardware more buffier. And let's say now, unfortunately, like we saw today, Azure fails, right? And we're hosting on Azure or whatever. And let's say it goes away, right? The whole database is down. That means that all of your users are affected. All of them. Rahul, Sonu, Jay, and Monu, right? They're all affected because it's fully down. But if we're using the sharding, and let's say one of them, let's say goes down instead of all of them, right? It could be the case where all of them goes down, but then I would really have to tell you seriously to consider a new cloud provider. But anyways, let's say one of them goes down. Let's say it's this shard over here, right? That means only Rahul and Jay are affected. All right, Sonu and Monu are not affected by that, and they can still use the application, right? Okay, so now that we have a very good understanding of how ElastiCache works and why it is scalable through this horizontal sharding technology that we just saw, right? I'm going to go ahead and give you a little bit of a rundown on how AWS works, all right? Because that's what we're using. All right, now AWS works through this visualization, okay? So this is just a, you know, a visualization that YouTuber Act They Mind, I believe, made, and it's a really good way of understanding AWS. So how it works is through your region, okay? So your region can be whatever, really. In my case, it is a US East 2, right? Okay, so it's based on your region, all right? And that's your parent, I like to say, cloud. But what happens is within that region, right, within that AWS cloud, right, that region cloud, AWS will actually make something called a VPC, better known as a virtual private cloud. It is kind of similar to a VPN. What it does is it logically isolates whatever is within that network, meaning that this VPC is not accessible by the internet unless you allow it through Network Access Control, or NACL, all right, which we can see over here. Now within the VPC, right, which again is pretty secure by itself because it allows you to basically whitelist only some networks that you see fit, right? You can obviously allow all the networks you want, but you have that option to only allow certain IPs to come through, which can be your front end interface or whatever it might be, right? Now, within your VPC, you're going to have something called an availability zone. So here we have two, but in my ElastiCache, we actually have three, which we can see through our network and securities and our subnet name group. I just named it bro. And as you can see, we have three availability zones, but they're essentially visualized exactly like this, right? They have a subnet within that availability zone because again, in the cloud, you must have a network for something to work, right? And what we're doing here is we're essentially modulating our network into two different child networks. All right, in my case, three different. And what this does is it actually allows for a fail-safe approach. Because let's say this availability zone goes away, it cancels, right? For example, the data centers within that availability zone is just a cluster of data centers, right? If all of them go down because there's a huge fire, right? I still have another availability zone which I can fall to. If I only relied on these data centers, right, and I didn't have another availability zone, my whole service would be down. But now it's just that I would have to brunt more load within this availability zone. Whereas in a like the ideal world, perfect world, Candyland, if you must say, you would have the resources distributed within the availability zones. And right, this is how kind of availability zone kind of looks like, right? These dots are just representing data centers, right? So it's just data centers that are close proximity with each other, and they just have different dedicated PCs, or sorry, I should say servers, which run your different instances, right? That you have within a subnet, right? Because again, you have to have some sort of network for there to be communication. So we do that through the subnet, right? Now, within each availability zone, which is powered by a subnet network, we can facilitate communication with other different instances, right? So for example, here we only see EC2 instance and RDS instance, but we have an ElastiCache instance as well. So what I did in my example is I actually use an EC2 instance, which is an Ubuntu server, and it is going to be connecting and communicating with this ElastiCache network. But by default, VPC does not allow intercommunication between instances. All right. So the EC2 instance cannot communicate with the ElastiCache instance because of a security group that is already by default configured. Like when you create the two different services, right? When you spin them up, there has to be security group by default, and it just blacklists everything. So it just means that this EC2 instance cannot contact the ElastiCache instance or any instance. But what we can do is we can configure the security group in the ElastiCache, right, to allow for an inbound, meaning to allow requests to come into the ElastiCache from the EC2 instance. So therefore, we are basically facilitating communication between both services. So essentially what security group does is it allows for communication between two instances within a VPC, right? They could be in the same availability zone or different availability zone. All right. Now that I talked about all this, let's go ahead and see it in actual action. So here I have my ElastiCache and I have my EC2 instance. I already have connected, as you can see, but I'm going to go ahead and cancel out, and I already have Redis CLI installed, right, as you can see here. But I'm just going to go ahead and go to my my ElastiCache, which is available at this endpoint, right? And the way that we can actually see that is by going here, going into my ElastiCache, right? And it's the configuration endpoint in this case because I'm using the clusters. The clusters mode is in fact enabled, right? But if it was not, and you just have one big database, right? Vertical scaling, in that case, you would just use the primary endpoint. Okay, now I'm going to go ahead and connect, and it's almost instant. All right. And now if you notice, if I go over here into my security and I actually go and see my security rules, security group over here, which is again basically just your security rules, and I just go ahead and open this up, you will see that I actually do have an inbound rule set in place, which is this one over here. If you guys didn't know, three 6379 is the port that Redis use by default for their services, right? For their databases, I should say. So essentially, we did was I just created a new inbound rule, and I allowed anyone to access this port, which is accessible, will be accessible by the ElastiCache, right? So essentially, anyone within my VPC can access this port, right? Not anyone from anywhere, but anyone within my VPC, right? Because again, the VPC is isolated from the broader general internet. And we'll see that in a second, actually. All right. Now that we know the theoretics and all that stuff, let's get into actually getting our hands dirty with AWS. So I spinned up an EC2 instance over here, and I also have my ElastiCache over here, obviously. And within this, I have 3 different shards, and they all have different ranges, as I've mentioned before. All right. So now, what I'm going to be using is I'm going to be using Redis CLI to do this, but this would also work with Node.js. Just ensure that Node.js is in a production environment with EC2, because that way it's in the VPC of the ElastiCache, or else it just wouldn't work, right? Because this endpoint that we have over here, this configuration endpoint, would just not be recognized, right? Because it's in a VPC. Additionally, when you're using this with Redis CLI, make sure that you use the /c command. Because notice what happens if I don't. Now, if I try doing something, right, like let me set name of like Hemet, I'm going to get this moved error. I'm going to get this moved error. And that's because this is anticipating not a Redis cluster, but just one big Redis database. So when it gets multiple partitions of databases, it gets confused and gives us this error. All right. So what we need to do is just make sure that we have this C command so that this does not happen. And this not might happen initially, but when you start adding new shards as your project starts, scaling up, and you want to use Redis CLI on a Linux-based system, or even on your local machine, if possible, right? You want to make sure that you want to do the /c. All right. So now I'm going to go ahead and press enter, and it goes ahead and starts it. And notice the difference now. If let me do set name to Hemet. You'll see that this is so cool. You'll see that it will redirect me to actually 001, Redis 001. What it's doing is it's actually posting this content, this name and Hemet pair to shard 1. And that's because the hash of name is slot 5798, which is within the range of, it should be cluster 2, my bad, not cluster 1, that's my bad. So cluster 2, and it's within the range of cluster 2, as you can see within here. There's 2 ranges, right? And it's within the second range. So there you go. Let's try something else. Let's set email to hemetvpatel@gmail.com. Put this in quotation marks and press enter. In this case, you'll see that it goes to 0001, and that's because the hash is for email is the number 10780, which is within the range, as you can see, of shard 1. Okay, so again, it's literally doing exactly what we have over here visualized, and it's actually even really cool, telling us where it's going, as you can see with the redirected message. The redirected message over here. Okay, so everything works perfectly. We can also so let me get the name. There you go. Let me get the email. So again, it's going to that shard specifically that holds the value, right? In this case, 001, and in this case, 002, and it's getting our value exactly as we want it to. So it's behaving exactly as we want. Additionally, all right, so this, I just showed you the how this works perfectly. Remember to use the /c option so that it actually knows that it's a cluster and not a big boring database. Additionally, this is all good and all well, right? But what's really cool and what really shows that this all works is if we try to access this on my local computer. So you notice that I'm actually using a EC2 instance to be able to go ahead and access the Redis server, and that's because again you need to be in the same VPC, which these two are, in order to access the services, considering that you have security groups set up properly. All right, but now let's say if I go into my terminal over here, okay, this is my local computer, and I try running the same command. Watch what happens. So I'm going to just copy this command, go ahead and paste it. You'll notice it's not instant. So, okay, maybe it's taking a little while. All right, waiting. As you can see, it's not working. And that's because this endpoint does not work on the internet. It's not available to the general internet, which is what this Redis CLI is doing, right? Because it's not on a virtual private cloud. It's just on the regular cloud, right? This is accessing on the regular cloud, while this is actually on the virtual private cloud of this, right? So that is why it's not working. And it's eventually going to say connection timed out, just like this. That happened. It's the same thing, right? So you can see over here, it literally just says operation timed out. All right. So that's just to prove that the VPC actually works, and it only would work on the ElastiCache service would only work on a instance which has the EC2. We can obviously set it up. We can obviously set up the VPC using the NACL so that we can access it through terminal. But this actually provides that extra bit of security, so that only people within the VPC allow it. So I'm going to keep it in default configuration, but you can just know that you have that option in NACL, so you can allow some people, or all if you want, but in a proper use case, some people from the broader internet to access this VPC service. All right, that is my AWS learning. I hope this helped you a lot, and this was my journaling.